Okay. Yeah, I ran out of time in the morning to do to talk to you more about random loading. So we're coming back to this example, we call this model. It's again, this basically is the random loading model, except now we're going to call it individual differences factor analysis. And I'm going to try to convince you that that we have to illustrate this new concept that the random loadings actually, even in cross-sectional studies, when you have a questionnaire, this data set that we analyze here showed us that individuals actually don't interpret the questionnaires the same way. And so even in cross-sectional studies, it would be good to have a way of adjusting the loadings for each individual to actually measure the same thing. Now, I'm not saying that I know how to do it, but I'll show you in this particular data set, which is a ecological momentary assessment data set. So ecological momentary assessment basically is a new type of data collection that basically records very frequently people's status within their natural environment. And you basically use these new electronic devices where they can collect the data more frequently than with usual surveys. And so you have multiple observations for the same individual. And once you have multiple observations for the same individual, you'll be able to evaluate the within person correlation matrices and evaluate also whether the same factor analysis hold for each person. So let's just look at the data set. The data set consists of 84 borderline personality patients. The borderline personality patients, the main interest for this study was to see how much fluctuation we have in the mood of the patients. And basically, the fluctuation in the mood is important. It's important concept because they wanted to see if people with borderline personality disorder can be distinguished from people with other depression, like regular depression, for example. And they wanted to see if people with borderline personality disorder have larger fluctuation in their mood compared to people with regular depression. So the fluctuation in the mood factor is the main issue here. We want to be able to measure the fluctuation of the mood factor within each individual. So the mood is basically measured by 21 self-rated continuous items. And each individual basically has about 100 assessments. They are done in this data set. Individuals are requested to record to answer this questionnaire about several times a day for 4 weeks. So it's a huge data set. We have about 100 assessments within each individual. And the original approach was again in two-level analysis where the cluster is the individual. And we have multiple observations within cluster. And again, this is actually a perfect data set to illustrate that people do not interpret the questions the same way, and that it's useful and helpful if you actually have a way of adjusting the loadings within each individual. And for example, consider this simple example here. If one individual answers items 1 and 2 always the same way, right? They just don't make a difference between the questions. You ask them 2 questions, and one person can be more self-aware than another person, right? And so some people don't make a distinguishment between two, whether they're irritated or they're jittery, say. Some words like that, and they kind of mean the same thing to one person, but they mean different thing to another person. So what does that mean? Can we use the same factor analysis for these two individuals? The answer is that we cannot. We actually need, what we have to do is for individual one, we actually have to throw one of these items away because it's not measuring anything different than the other item, right? So they're measuring the same thing. So we cannot be using the same factor analysis for the same individuals. And the question is really, and that you see that in this analysis we actually find that particular thing where the loadings have to be individually specific. And the question is, how do you really do this in cross-sectional studies? Should, this opens up a lot of design questions. Should really be, the measurement instruments be tested in a way where you can actually evaluate this with the same individuals and evaluate this invariance across the individuals, really. But that's something that I'm not addressing. Actually, I'm just going to show you how we're going to measure, how we're going to incorporate individual-specific loadings, how we're going to distinguish the individual-specific loadings from individual-specific factor variance. I talked in the morning about this. The two concepts are confounded. We need actually a model that can easily separate the two things in a meaningful way. So, I'm lost here. Sorry. So, here's the model that we're going to consider that has random loadings and I'm actually lost myself here somehow. Okay, anyway, so the point is, what I want to address here is that we need a model that is going to naturally separate the variation across individuals in the factor variance and the variation across individual in the factor loadings. So this is the model that we're going to consider. This YPIG is item P for individual Y in assessment J, and we have an individual-specific predictor X. And we have the usual two-level model, which is basically the fixed mean for that item, and then you have an individual-specific mean. And again, we have the random loading multiplying the factor and the residual. Each individual has a individual-specific factor mean that's regressed here on this covariate, and the residual within level residual. And I actually, in the pizza example in the morning, I kind of illustrated the fact that the way to think about the difference between the factor variance variation across individual and the loading variation across individual is that the factor variance is the common change in the factor loading. So essentially this sigma I here, which is essentially a factor behind the random loadings, is essentially the variance of the within level factor. Because again these two concepts are confounded, the factor variance variation and the factor loading variation, the easiest and the simplest way to actually separate these two concepts is to actually use this model, which is basically a factor model for the random loadings. And that's the factor model for the random loadings. Again, the common change in the factor loadings is attributed to be the change in the factor variance. And you can also regress now this between level random effect, which is the factor variance on the same predictor, and the two coefficients beta 1 and beta 2 simply represent the effect of the covariance on the factor mean and the factor variance. So in these two equations, and yeah, this model is very simple to set up in Mplus. Again, random loadings. The variance is fixed to 1 because the factor-specific variance is pushed into this factor between level factor sigma. In the setup here, you see that the mean of the random loading is the same as the loading in this two-level factor. So that's basically this setup right here. That you have the mean of the random loadings are held equal to this factor model on the between level where the factors, you have a common factor for the random loadings, and these are the regressions of f on x and sigma on x are these beta 1 and beta 2 coefficients. And just show you some of the results here. So this is the residual variance. For each item, you get a residual variance, which is basically the variance on the within level. You get the mean parameter, the variance of the mean, which is basically the variance of this individual's the random intercept. You get the loading, which is the mean loading, the loading of the mean of the random loading, variance of the loading. And again, this you can see here that these are quite big, the variance in the loading, again, which is, illustrates the concept that indeed we can actually find this in the data, that the individuals actually interpret the questionnaires differently, and a simple factor analysis model with the same loadings for every individual cannot explain these correlations that they have in the answers. So the correlations within individuals are different, and so you actually you have to adjust the factor analysis model for each individual to be able to reflect what the data says and to actually measure their moods properly. But the most important thing here in this, and you can actually here we can compute also the percentage loading invariance, which is basically the percentage of the variance of the loading that's explained by the factor variance variation, the common variation in the loadings. But so the two important things here to take home is that we do have a model that is nested above the model that. Okay, let me just, excuse me, sorry for this. Let me just illustrate here two concepts. Now, if you have loading invariance, what does that mean? That this variance parameter, the variance of this will be 0, right? So this model contains the loading invariance model as a special case. And also if you have variance, factor variance invariance across individuals, that means that the variance of this, that this term is 0, right? So this model actually would contain as special submodels the models of loading invariance and factor invariance, and it basically accommodates both concepts inside this model, and it naturally separates the two. So one more sentence that I want to say about why we're so excited about this model is because you know, when you do a factor analysis model, what happens is that the common factor. So you have what you're feeding with the factor analysis model is a correlation matrix, right? And the factor analysis model tries to absorb as much of the commonality into the factor, right? And the same thing is happening here, except it's on it's on a higher level. So the factor variance absorbs as much of the variation across the loadings. So that's basically the common change in the factor loadings is basically the factor variance, and both of these concepts are random at that higher level. So so the bottom line is of this model is that there is a way to separate the variation in the factor variance from the variation in the factor loadings in a very natural way. And the second thing that you want to take home is that this model, which we call the individual difference factor analysis model, it has everything is individually specific. You have individual specific mean, you have individual specific factor loading, you have individual specific factor mean, and you have individually specific factor variance. So there's all these four components are individually specific, and you can, again, that kind of opens a lot about, should open discussion about how much of invariance do we really have, and how appropriate these models are that apply the same measurement to different, use the same measurement to different individuals when the individuals actually don't respond the same way, and they don't mean the same thing when they respond to these measurements. So that was the hard part of this topic, and I think we can move back to our regular order of the slides there, back to...
Let me see if they have some questions on the
yeah.
three-step over lunch.
Okay, yeah, go ahead. Yeah. Yeah.
You have a microphone coming up.
Doesn't this suggest that the loading is negative? So you have opposite sign for curves of different people. Or if you look at item 1, how correct is that?
So that's a good question, actually. You talked about that. You know, you have some of these anchor items that can't go negative. So I don't think that there's a sign flipping here. Because, yeah, look at item 2. I mean, you know, there's 21 items. It's very difficult to reverse 21 items. But, yeah, look at item 2. That doesn't go negative. So... Uh-huh.
We can also take questions on the three steps.
Yeah, if you guys have other questions. Yeah, go ahead.
I have a question on this.
Yeah?
Sorry. I was wondering to go back to the research question
Uh-huh.
about borderline personality disorder.
Yeah.
I'm wondering if there's a meaningful way to interpret these research in terms of if people have borderline personality disorder or more, because you have like, sorry, I'm not clear. You have like a variance in the loadings.
Mm-hmm.
Can you clearly like distinguish clusters or so between people that have that vary much over time in their emotions here and people that don't? Because I think that this will be a mess. Like people will be different in all sorts of, in all kinds of ways. Does it make sense?
Well, so here's what I'm going to say about this. So, what we actually brought to this analysis, actually, with this new analysis, is the fact that there's not just variation across. People have individually specific variation in their factor mood, in the mood factor, right? But that's actually confounded also with the measurement error. With the problem with the fact that the loadings are not the same across individuals. So there's the variation in the random loadings across individuals. The loadings are not the same across individuals, and we can confirm that with these models. And also the variance, the factor variance changes across individuals. So the two things are confounded, and that wasn't basically discussed before. But that's what the idea. If you have a reliable way of measuring the factor variance for each individual, that's perfectly, that's a great way to look for, evaluate and see how.
But can you meaningfully interpret that?
I-
Can you meaningfully interpret that when these lambda parameters are varying so much across persons?
Can you meaningfully interpret it?
I understand that you distinguish the variance
From the factor variance.
below here.
Uh-huh.
But how would you interpret the variance when these constructs differ so much across persons? Because the loadings differ so much.
Well, they shouldn't really differ that much. They don't, in principle, I just reported here the first 5, the 21 items here, so that shouldn't be an instrument that, I think the scale should be the same, and, I don't think the loading variation is that big here. So that's my answer, that, I don't actually have the results for the rest of the 21 items, but actually, it's a fairly big instrument, so I think the scale is the same, but...
Tihomir, can you identify from this analysis which items are inappropriate for comparing individuals because they have too much cross-individual variation? And can you tease out which individuals are so different from others?
Well, I guess that's another point of view that, generally, when we talk about, the quality of the items, we usually look at the loadings, right? But what are we going to decide about a loading that has a, larger variance now? Not just mean, but, we have to look also at the variation across individuals. So perhaps that's also another concept that has to be rationalized substantively somehow, and we have to decide of what to do with these items as well, and perhaps maybe some items should be thrown away to actually eliminate these problems that you just mentioned. That maybe we need just to look at the items that have a smaller variance so that we can ensure that the scale is the same. Yeah. Yeah, I would say also that, if you have enough anchor items that don't have that much variation, those will guarantee that the scale is the same. To be honest, we did not look at this as actually, change the, so basically when we did the analysis, I wasn't looking at a substantive conclusion here. So you have to, for me, this was an example, basically, not something that I wanted to change the way, that this particular data set should be analyzed. But it's just an illustration of what you can do. You can actually use predictors here. And basically, so the original design here, maybe something will ring a bell, they actually had, out of these 84 patients, they had 40 of them were true borderline personality disorders, and the rest of them were regular depression people. And that was the idea. Can we actually use this binary predictor, which was an indicator for the borderline personality disorder? Was this beta 2 coefficient, was that coefficient actually significant? So was it actually increasing the variance of the borderline personality patients? And this analysis, that the way I ran it, it showed that it wasn't. But again, I might need to go back and reanalyze and maybe consider some of these issues that you guys are bringing up. Maybe that, there may be some issues with science and things like that and other things.
Our modus operandi is that we throw out the wild idea that we can do statistically, and then we present it, and then we hear opinions about it from substantive researchers, and then we take our best ideas and put it into our paper.
Yeah.
I'm assuming that the measurement equivalence literature applies here, and the bottom line there is basically that we need at least 2 loadings that can be assumed the same across all individuals. So you're looking for at least, I would like that more, but you look at least 2 loadings that have virtually 0 variance. I'm guessing that would apply.
Yeah, I think that sounds correct, yeah. Any other questions? Okay. There is a second microphone too.
All the questions here, and anybody can pick up and do the relay race back and forth if you want to have a lecture exercise.
Yeah. Did you want to ask a question? Yeah.
Okay.
Yes, I think this movement towards studying variance is a very interesting one. And what struck me was that up till now you have given examples in which the variance in a sense was a nuisance, because with these individual differences in factor analysis, then you don't want them to exist. But there are also all other kinds of research are thinkable in which they are not a nuisance, but in which they are something that should be studied. So, for example, I did a research on how difficult people found using educational technology for different tasks, and there the fact that there were tasks on which there was a large variance in how difficult people it found, and there were tasks on which there was a very small variance in how difficult they found it to use the educational technology, in itself was very informative. And I think if you got this second type of research, then there are also other things will be needed other than looking whether the loadings will differ from the average or something, but that kind of clustering or so will be needed.
Yeah, I think...
Tihomir, I think the request is to add mixtures on top of this to find the individuals who are very varying.
Yeah. But yeah, it's again, it's now with this kind of analysis you get the regular loading, which you kind of want to discount item. You don't really want items that have poor loadings. But now you also have the variance, so you have to decide what to do when the variance is large. So yeah. I think this mic, there's another mic here. I don't know if you want to use it. Sorry.
I have a question about LTA.
Uh-huh.
Is it possible to use the three-step method in LTA?
That's good. That's exactly the kind of question we want to have now.
Yes, and the answer is yes, but you have to do it manually, the way I kind of illustrated with that example. So you're going to have, you can use, do your LTA and get most likely class membership variables, and then use these as indicators in the third step. As far as I know, nobody's ever done this before, so yeah, welcome, yeah, just give it a try. So, yeah, but yeah, that's, yeah.
I'm thinking on the slide, second vision, page 1 to XI, and you can also insert add XIJ, which is the lowest level covariance equation.
Are you asking about the question how do you use Xij here?
No, in that equation, second equation, you have the page 1 for XI, and this XI is the individual level covariance.
Yes.
And for this, can you also add the lowest level covariance?
I think you asked me that question last night, right? Yeah, this is the same question. You're formulating it slightly differently. And
That one is for the loading, but this one is for factors.
oh, for the factors.
Yeah. You see this?
Oh, yeah. That shouldn't be a problem at all, right? This you can add. Yeah, right, Bengt? That shouldn't be a problem. Yeah, you can add here a covariance. Yeah, that changes the mean. Yeah.
You cannot add this fact value to the loading.
Yeah, you cannot do it this the same way. Yeah, we still sort of I asked that we've been talking about that diff, how to do the diffing but we haven't come up with a conclusive answer to that. But here you can add here you can add xij for sure. And this is basically as simple as just to bring the input, I guess. You can just add covariates here, right? Yeah. Yeah.
Slide 100.
100. Okay. Oops.
This B1 to B6.
Oh, sorry, 100. Yeah.
This B1 B6 is the orthogonal element of the matrix for U1 to U4. Right?
It's the correlation matrix. So you have 6 correlations, and because these are categorical variables, right? So the variance is not identified. The variance is fixed to 1.
Okay, and the model corrects this P1 P6 follows inverse distribution distribution.
Yes, that's right.
So this is this matrix called inverse distribution.
So basically, the way we specify in Mplus correlation matrices, correlation matrices don't have explicit distributions, so they're the marginals of the inverse Wishart. And basically, this is the way to specify the degrees of freedom, and these are the you only specify the off-diagonal elements in the inverse Wishart prior matrix, and the diagonal elements are 1, and you don't have access to those because they're just nothing to specify. They're not, the variance parameters are not part of the this matrix because it's a correlation matrix. But if you actually had continuous variables here, then you would have a statement like that, and also a statement that goes from here to here, basically just the variance parameter statements. It's going to be 4 variance parameters. And then here you have to specify V1 through V4, distributed as inverse Wishart with 1, 15. So yeah, we don't have an example, unfortunately, with how to specify it, but in the slides, but that's,
So I think we have to stop the moving
Well-
questions today to move on. I'm glad that this new idea here has generated so much interest, and the 3-step as well. But we want to move on, but we can take some more questions at the end, particularly since it then spills over into the computer session. I'd like to take the opportunity to welcome a new member of the participants. This gentleman comes from Ghana. Welcome, Bruce. Was it Bruce? Yeah. And he looks for the group from South Africa. Where are you located now? Raise your hand so he wants to meet you.